Lesson 5.3, Linear Relationships and Bivariate Data. Lesson 5.3, Linear Relationships and Bivariate Data. Example 1, finding the equation of a linear relationship. You can use the points on a graph of a linear relationship to write an equation for the relationship. The equation of a linear relationship is y is equal to mx plus b, where m is the rate of change or slope and b is the value of y when x is 0.
You know, lines are all around us, and we can actually see lines in even works of art and things around us, even on stairwells. In fact, that reminds me of a little riddle for us. So let's take a look at this challenge, see how we make out together. A part of a wall mural design is made of a straight line that runs above a step pattern. As the horizontal distance from the bottom of the first step changes, the height of the straight line changes. Our challenge is to show the relationship is indeed linear, and then see if we can find the equation for the relationship. Sounds like kind of a contrived question, but here's the fun thing. They gave us all this information. This picture says it all, and this is where the math is. So you can see on the x-axis we have the horizontal distance in feet, and on the y-axis we have the height as we go up in feet. And you can see all these points are given, and the coordinates are given by these ordered pair 5, 8, for example, and so forth. So, okay, well, first of all, let's just see if we actually can model these points with a straight line. So I'm actually going to try to draw in a straight line right now live. Let's see what happens. Now, drawing straight lines, this is really tricky. If you have a straight edge, that's really great. So actually, I do have a straight edge right here I could use, but that's no fun. I'm going to try to do it right now live. So here we go. Wish me luck. Here I go. You got to kind of visualize it. Hey, that's actually not bad at all. So something like this allows us to see that it looks like it is kind of a straight line. If you want to see really, really fancy version of this, I can actually show you that too. So let the bad one go away, and we'll just say bleep. And what I'm going to do is actually right now, live, bring on a beautiful straight line that goes right through those points. Look at that. It's like Cupid's arrow. Isn't that lovely? There we have it. Now, the nice thing about this is that we can really see precision here, which is good, because remember, we're supposed to now find the equation for this line. It certainly looks linear, and now we want to see if we can actually find the equation for this line. Well, okay, so that means if we're going to write it as, let's say, y equals mx plus b, what we have to do is we have to find the slope m and then the y-intercept b. Now the y-intercept, this means where the line crosses the vertical or the y-axis. Now see, it's kind of hard to see. It looks like it's not 0, but it's kind of close to 0, so it's not quite clear. We just can't read it off. We actually have to do some math to figure it out. But first, let's find the slope. Now, you know how to find slope. What we do is we look at the change in y over the change in x. So we have to pick 2 points, and any 2 points will do. They'll give us the same answer. So how about if I pick this point right here? This is 5, 8. And just for fun, I'll pick this point way out here just to show you it doesn't make a difference. I'll pick 25, 32. So looking at these 2 ordered pairs, we can now actually find the slope. So what would the slope equal? Well, the slope is going to be the change in y's minus the change in x. So I take the 32 minus the 8, and I divide that by the 25 minus the 5. Now, lots of classic mistakes here. Let's make sure we don't make any of them. Remember, we take the y values on top, so it's y, and then minus this y. And then if I start with this ordered pair for the y's, I have to start with this ordered pair for the x's. So it's really important. If I have the 32 up front here getting top billing, then the 25 has to get top billing downstairs, right? And if the 8 gets second billing here, then the 5 has to get second billing here. As long as you're careful, you always get it right. So, what does this equal? Well, 32 minus 8 equals 24. And 25 minus 5, that's 20. So this actually simplifies to 12 over 10, which is just 1.2. So we actually see that the slope of this line is, in fact, 1.2. Well, that's great progress. So let me just write that in because that's kind of fun. So y equals 1.2x, but then we still don't know what the y-intercept is. So now our mission is to figure out what the y-intercept is. Well, how can we do that? Well, one thing we can do is, since we know that this is going to now represent the equation of the line, if we plugged in any one of these known points that are on the line, the x value here and the y value here, then in fact this has to be an equality, which means we can now solve for b. So let's try that. Let's just pick the easiest point, which is the smallest values, 5, 8. So if I try this, here's what I'd see. I'd put in an 8 for y, so 8 equals 1.2 times the x value, which is 5, and then plus the mystery b. So check it out. There's the coordinates 5, 8, x, y. Okay, but now everything is a number except the b, so we can figure this out. So we see that 8 equals, and 1.2 times 5, that's easy, that's just 6, plus b. And now if I subtract 6 from both sides to undo the addition of the 6 here, we see that 8 minus 6 is just 2. And so I see that b equals 2, and that's the b value. And so now I can come back and write the equation of the line once and for all. Y equals 1.2x plus 2. And that, in fact, is a description of this line that we saw from this part of a mural. And the cool thing is that this doesn't just hold for the points that we were given, but it will hold for any point along this red line. So any x, y pair that lies on this red line, if you plug in the x value here and the corresponding y value here, these two quantities will be the same. That's the beauty of looking at equations for lines. It allows us to actually write down a general equation that will always hold for any point on the line. Lines are all around us. And as we embrace not only the visualization of lines, but actually writing down the equations of line, it's nothing but sheer fun and joy. I love lines, and so do you.
Okay, a couple of things to take note of on this particular example. Look at the graph. Notice that you cannot count the slope. There's no way you can count it. And notice that you're not exactly sure what the y-intercept is. That means you must determine everything from the data that's given within the graph. Once again, you must determine everything from the data that's given within the graph. Once again, quick review. You write down your equation, y equals mx plus b. You find the slope. Now, you find the slope by working with any two sets of points you want. You can take this set and this set. You can take this set and that set, that one and that one, that one and that one. Doesn't matter what two you pick. Normally, you try to pick the easiest two or the lowest numbers to work with. Like if I were doing this, I would have picked this one and this one. It does not matter what two I pick. So long as I do the correct math, my answer will come out to be 1.2 or 24 over 20. And of course, reduce that down. Now, after you find the slope, then you want to find your y-intercept. And the way you do that is, just in case you couldn't see exactly what they did, the way you do that is you take any point and plug it back into the original equation along with the slope that you found. So the easiest point to work with, or the smallest one to work with, is 5 and 8. So here, I got y equals mx plus b. My y value is going to be 8. My slope I found was 1.2, so I put down 1.2. My x value is 5. Then I say plus b. All right, now that's how he got that. So after that, the math is kind of simple. 1.2 times 5 comes out to be 6. So now you got the 8, you got the 6, and you got b. So then to find b, all you got to do is get rid of that 6. It says a positive 6. So below it, you're going to put a negative 6. And here you're going to put a negative 6. So now what is 8 minus 6? That's going to be 2. And of course, right here, the positive 6 and the negative 6 is going to cancel out. So B is going to equal to 2. So your final equation then is going to be y is equal to 1.2 slope times x plus 2. And that's it.